Now let us proceed our discussions with installing the strain gauge on reinforcing bar. In previous videos, we mentioned about several key points that you need to pay attention while installing the strain gauge on reinforcing bar. The principle was to minimize the effects in terms of the reductions of the tensile capacity of the steel bar, reductions of the bond strength between the steel bar and the concrete, protections of the strain gauge and the lead wire against harsh environment due to the casting work of the concrete. These are the precautions that you need to pay attention for you to acquire accurate measurements. In these videos, we're going to proceed our discussions in terms of the installation process. First is about the surface preparations. This we mentioned slightly in our previous videos. You will need a flat surface for the strain gauge to be firmly attached to the reinforcing bar. You will require about 25 to 30 mm area for the installations of the strain gauge. Identify the locations where you need to install the strain gauge, and then identify which ribs you need to grind off in order to acquire the flat surface on the reinforcing bar. Do not grind the longitudinal rib, as this will affect the tensile capacity of the reinforcing steel bar. You can choose to grind the horizontal ribs. Now, use a grinder, remove the horizontal ribs. Once you've done the grinding, you will need to clean away the black iron oxide deposit from the reinforcing steel bar by using wire brush. Make sure you remove all the impurity before installing the strain gauge. Next, use tape to mask off the area around the gauge installation site and attach the integral lead wire strain gauge with CN adhesive. Regarding the methods of installing strain gauge with CN adhesive, you may refer to the previous videos. And then, attach the strain gauge facing the opposite directions to that in which the lead wire will extend when installation is complete. What does it mean? It means that the directions of the strain gauge is theoretically be applied in the opposite directions of the extensions of the lead wire. I believe this is to minimize the tensile stress applied onto the strain gauge in the case that there are any disturbance to the lead wire, which the pulling force may ultimately lead to disconnections of the gauge lead, which is very fragile, from the strain gauge. If the gauge lead snaps, the strain gauge becomes not functional. Next, it will be applying the coating onto the strain gauge. You can have the W1 as the first coating. The applications of W1 coating we have discussed in our previous videos. Basically, you will need to heat the W1 until it liquefies, and then use a brush to paint the W1 onto the strain gauge, including the lead wire. You will need to apply a multiple layer of W1 onto the surface of the strain gauge to secure the protections against water and moisture. As these reinforcing bar later are to be embedded inside the concrete, a harsh environment is expectable. One single layer of W1 first coating may not be sufficient. You can consider to apply the second coating, which is the SP tape. We have discussed about the process of installing the SP tape coating. You may refer to the previous video. You will need to prevent the water leakage where the lead wire emerged from the first coating. as a precautions to the first coating W1. Then you apply the SP tab. And then you will need to fold back the lead wire and secure the lead wire to the reinforcing bar. Something like this. You may tie the lead wire onto the reinforcing bar, taking the reinforcing bar as a support to prevent the movement of the lead wire during the casting of the concrete. Next, cut a piece of VM tape and wrap the tape around the steel bar. By now, you will have 3 layers of coating. The first coating, it will be W1. The second coating, it will be SP tape. And now the third coating, it will be the VM tape. Lastly, you apply the self-bonding tape, which is known as the high bond tape produced by the company here, and wrap the tape around the VM tape. The purpose here is to keep the coating in positions. By now, this self-bonding tape, it will be the 4th layer. Up to this stage, theoretically, you have sufficiently prevented the water and moisture from reaching the strain gauge. Knowing that there will be a harsh environment for the strain gauge when the reinforcement bar is to be embedded in concrete. In order to protect the strain gauge against physical damage, you may require an additional layer of coating using the bandage and P2 adhesive. We also talk about the P2 adhesive and its installations in our previous video. Basically, you are using the adhesive together with the bandage, which this bandage can be applied at multi-layers to provide protections to the strain gauge against the physical damage that can happen during casting of concrete. This will be the 5th layer of protections for the strain gauge. Now that the coating applications is completed, what you see here, there are so many layers of protections given to the strain gauge for an accurate measurement of the strain gauge. The strain gauge cannot be exposed to the moisture and water. Now, since the reinforcement bar is to be embedded in the concrete, especially during the casting of the concrete, there will be physical movement and the strain gauge can be easily damaged. You will need to provide protections against this physical damage as well. Now, the entire process of installing the strain gauge until finish the coating will have to be done carefully with the principles to minimize the effects onto the test specimen, as your ultimate goal here is to measure the conditions of the test specimen. As a result, the performance of the test specimen shall not be significantly affected due to the installations and coating applications of the strain gauge.